Electrical installations for cylinder tank filling stations, including those utilizing SCUBA compressors, require careful consideration even though the National Electrical Code, or NEC, does not have a specific article dedicated to them. Several NEC articles, however, provide general requirements that apply to these installations. The goal is to ensure safety and compliance with electrical standards, mitigating risks associated with electrical hazards in potentially hazardous environments. Firstly, consider Article 500 of the NEC, which covers hazardous classified locations. Depending on the substances handled at the filling station, the area might be classified as a Class 1, 2, or 3 location, and divisions 1 or 2 within those classes. For example, if flammable gases or vapors are present in the air in sufficient quantities to produce explosive or ignitable mixtures, the area would be classified as Class 1. Division 1 locations are those where hazardous materials are present under normal operating conditions, while Division 2 locations are those where hazardous materials are present only under abnormal conditions, such as a leak or spill. The classification will dictate the type of electrical equipment and wiring methods permitted in that area. Explosion-proof equipment, intrinsically safe systems, or other approved methods are required to prevent ignition of the hazardous materials. Secondly, grounding and bonding are critical for safety. Article 250 of the NEC provides comprehensive requirements for grounding and bonding to ensure a low impedance path for fault current, which helps to prevent electrical shock hazards and minimize the risk of fire. All metal enclosures, equipment, and non-current carrying metal parts must be properly grounded. Bonding jumpers should be used to connect different metal parts to create a continuous electrical path to ground. For filling stations, proper grounding is especially important to dissipate static electricity, which can build up during the transfer of gases or liquids. Thirdly, wiring methods must comply with Article 300 of the NEC, which covers general requirements for wiring. The type of wiring method used will depend on the location and environment. In hazardous locations, specific wiring methods such as rigid metal conduit, or RMC, intermediate metal conduit, or IMC, or cable types specifically listed for use in hazardous locations are required. Liquid-tight flexible metal conduit may be used for short runs in dry locations, but it is essential to ensure that all fittings are properly installed and suitable for the environment. In wet locations, wiring methods and enclosures must be suitable for wet conditions. Corrosion-resistant material should be used in areas where corrosive substances are present. Fourthly, overcurrent protection is essential to protect electrical circuits and equipment from overloads and short circuits. Article 240 of the NEC provides requirements for overcurrent protection devices such as circuit breakers and fuses. The size and type of overcurrent protection device must be appropriate for the ampacity of the conductors they protect. Motor circuits, which are common in compressor applications, require specific overcurrent protection according to Article 430 of the NEC. Motor overload protection is necessary to protect the motor from overheating due to excessive current draw. Fifthly, disconnect switches are required to provide a means of disconnecting electrical equipment for maintenance and repair. Article 430 and Article 440 of the NEC cover the requirements for disconnect switches for motors and air conditioning and refrigeration equipment, respectively. Disconnect switches must be readily accessible and capable of being locked in the open position for safety during maintenance. For equipment located in hazardous locations, disconnect switches must be suitable for use in those locations. Sixthly, specific requirements apply to equipment installed in damp or wet locations. Article 680 of the NEC covers swimming pools, fountains, and similar installations, and although not directly applicable to filling stations, it provides guidance on equipment suitable for wet locations. Equipment installed in damp or wet locations must be listed for such use and protected from water ingress. Enclosures must be weatherproof or watertight depending on the severity of the environment. Seventhly, consider the use of surge protection devices, or SPDs, to protect sensitive electronic equipment from voltage surges caused by lightning or other transient events. Article 280 of the NEC covers SPD. Surge protection is particularly important for compressor control systems and other electronic components that could be damaged by voltage spikes. SPD should be installed at the service entrance and at any sensitive equipment. Eighthly, when dealing with SCUBA compressor systems, special attention should be paid to the motor and control circuits. Compressors often use three-phase motors, which require properly sized conductors and overcurrent protection. The control circuits for compressors may include pressure switches, temperature sensors, and other control devices. These control circuits must be wired in accordance with the NEC and the equipment manufacturer's instructions. Ground fault circuit interrupters, or GFCIs, may be required for receptacles located in wet or damp locations to provide additional protection against electrical shock. Ninthly, it's crucial to ensure that all electrical work is performed by qualified and licensed electricians who are familiar with the NEC and local electrical codes. A thorough inspection of the electrical installation should be performed by a qualified electrical inspector to verify compliance with the NEC and other applicable standards. The inspector will check for proper grounding, wiring methods, overcurrent protection, and other safety requirements. Tenthly, documentation and labeling are important for maintaining a safe and compliant electrical installation. Electrical panels and equipment should be properly labeled to indicate their purpose and voltage. Wiring diagrams and other documentation should be kept on file for future reference. Any modifications or additions to the electrical system should be documented and inspected to ensure continued compliance with the NEC. 11thly, the local fire department's requirements may add another layer of safety protocols. Fire departments often have specific regulations related to the storage and handling of compressed gases and the electrical equipment used in these facilities. These regulations may be more stringent than the NEC requirements in some cases. It's crucial to consult with the local fire marshal to determine any specific requirements that must be met. In summary, while the NEC does not have a specific article addressing cylinder tank filling stations, several articles provide relevant requirements that must be followed to ensure a safe and compliant electrical installation. These include articles covering hazardous locations, grounding and bonding, wiring methods, overcurrent protection, disconnect switches, equipment in wet locations, surge protection, and motor circuits. The installation should be performed by qualified electricians and inspected by a qualified electrical inspector. Consulting with the local fire department can provide additional guidance and requirements. Understanding these key aspects is critical for safely setting up a cylinder tank filling station.